you for your introduction. I am Professor Moktar HAMDI from Tunisia, University Carthage. I will present the work of my student. She couldn't be here. This work is part of his PhD, optimization of Chlorella sorokiniana growth in treated wastewater cultivated with ashes using response surface methodology to produce high added value, especially for now is biomass. My presentation are 5 parts: introduction, problematics, objectives, and after that we describe material and methods, and research and discussion. As you know, microalgae is a photoautotrophic eukaryotic microorganism. He uses water as primer electron donor and oxygen as CO2 as a terminal electron acceptor. He has many applications like plants, but now we have many dreams to solve many problems of environment by using microalgae in some photobioreactor. We have raceway, and we have now we developed some closed photobioreactor. In the world now we have many applications about to use microalgae in wet biotechnology to produce biofuels like biodiesel, and we use microalgal biomass to produce some polymers like starch, sugar, and we also in environment we can use this microalgae to fix CO2, and then we contribute to mitigate climate change. We have also other applications in agriculture, especially in aquaculture to feed fish. Also, we have in red biotechnology, in pharmaceutical technology, and also in health, and especially nutraceutical compounds and products for the future. To develop microalgae at high scale, I think we have many limitations now, especially media, selected microalgae, and especially photobioreactor. Now we have some photobioreactor in the world developed. We have especially closed, especially when we have to produce in pure culture in such application in pharmaceutical and food application. We have tubular, we have flat reactors, serpentine reactor. So, but I think the light diffusion in this photobioreactor remain a challenge. In our lab, we developed some reactor from raceway. We developed other reactor, airlift reactor, and in tubular reactor, and now we have serpentine reactor. We have such species and strains about microalgae, and we good growth, and especially bioflocculation. Our problematic to solve was the production of biomass. Microalgae needs especially nitrogen and carbon, and especially nutrients. We used wastewater, treated wastewater, and we try to use other mineral sources. We tested the culture of Chlorella sorokiniana on the treated wastewater by testing some ashes issued from woods, sludge, and leaves. So we used these elements to optimize growth. and to assess the biomass and lipids production. In our lab, we have these strains. We have some steps to develop the inocula. These steps, the strains of microalgae has some characteristics. And we use, especially when we isolate and to develop strains, we use BG11. We tested we analyzed the urban treated wastewater and the mineral solution issues from ashes, and we follow the growth, and we performed our growth in Erlenmeyer, 250 milliliters and 22 temperature. We have 2 cycles of light under pH 7. The duration of culture is about 20 days. To optimize the Chlorella sorokiniana growth, we used the matrix of BoxBehnken experimental design. We tested 3 factors, especially to optimize the carbon to nitrogen ratio. We used nitrate, carbonate, and mineral solution. We used 3 levels to optimize this growth by assess the biomass growth, the chlorophyll A, and the lipids. Well, after 20 days, we analyzed the biomass and the chlorophyll and the lipids, and we observed that some experimentation give us better biomass growth and lipids. It depends. Especially when we have high level of carbon and nitrogen, we produce biomass. But when we have limited carbon and biomass, we can have a higher content in lipids. When we try to calculate the coefficient of the response of biomass and lipids production, we have some the high coefficient about nitrogen and carbon, about biomass and chlorophyll production, and we have a highest level coefficient about mineral solution about to produce lipids. The optimum was confirmed, and we have predicted response much good with experimental responses about biomass, chlorophyll, and lipids, and so we can conclude what we have about 2 grams and 2 grams of sodium nitrate and 2 grams of nitrate hydrogen carbonate, and about 100 milligrams of mineral solution from ash. Here we can compare the obtained performances on to compare growth of the Chlorella sorokiniana in the BG11 medium, urban treated wastewater, and the optimized urban treated wastewater with addition of especially carbon, nitrogen, and mineral solution. We increased the final biomass and the kinetic of growth, and especially the productivity was multiplied 11 times in comparison to the raw urban treated wastewater, and we have improved the lipid content in the obtained biomass. When we draw the surface, the responsive surface, it confirms the obtained coefficients and results. To conclude, we can say that treated wastewater treatment can be used as medium to produce microalgal biomass, but you have to add some elements, especially carbon, nitrogen, and some minerals. But this PhD is with goal to produce lipids, but in our team, our goal to solve the problem of physical-chemical condition, and then in order to optimize the bioreactor. But when we have problem of limitation of growth, we can't improve the bioreactor configuration and operation. Thank you.